Hi friends, in this video we are going to look at problem 1371. Find the longest substring containing vowels in even counts. In this video we are going to use the exclusive OR. So this is one ingredient of this solution. So essentially we are going to use a technique called dictionary and check. So first I'm going to quickly read through the problem statement, and then we are going to look at the analysis, and finally we look at the code together. So here we are given a string. We want to return the size of the longest substring containing each vowel with an even number of times. So here the vowels are those 5 characters. So appearing even number times actually include appearing zero times. So here we have 3 examples. The last example is very special because it does not contain any vowels. So the length actually is the length of the string itself, that is 6. We can use example 1 as a example. So here the longest substring is this one. So you can count the frequencies of those 5 letters, right? So these 3 letters contains all appear 3 times, while A and U do not appear, right? So also the length of this string is can be as long as 5 times 10 to the power 5. So in other words, this is very long that you need to, it's so long that you need to consider time complexity in your algorithm. So, and S contains lowercase English letters only. So with that said, we are ready to do the coding. So the thought is the following. So we want to be able to monitor the frequencies of each letters. But here we only care about if the letter appears even number of times or odd number of times. So actually we can use exclusive OR to do this. So we can actually assign each letter a bit position. For example, from right to left, we can use bit position 0, 1, 2, 3, 4 to monitor A, O, E, I, U, right? So this is the bit position for A, this is bit position for 1. So this way, once we established this thought, so we can use a single integer to monitor the frequencies. So if a vowel appears even number of times, then the corresponding bit position shall be 0, right? This is due to the cancellation property of exclusive OR. If all vowels appear even number of times, then the integer itself, or equivalently all the bit positions, should be 0, right? And then the number must be 0 too. So here by the cancellation property, we mean that, so if you have an exclusive OR result of this array from index L to index R, then you have another one from index L to index I, then there must holds starting from index I plus 1 up to and inclusive of R. So the exclusive OR result is also 0. So actually, once we realize this, then the problem is transformed or reduced to a standard problem. That is, find the longest substring length here, such that the exclusive OR equal to 0, right? So this is actually a prototype problem. So we could use the dictionary and the check strategy to solve it very easily. So if you haven't practiced such problems, so you can think of this problem: find longest substring, subarray, right? Such that the sum is 0, right? Or let's say is k. So k can be 0 or something else, right? So this is the typical problem prototype. So with that said, we can design the code for this problem. Now, we can use the vowels because we want to set bit positions. So we first assign the bits. So assign the bit positions for vowels. So here I do this explicitly. Actually, you can do it implicitly, but for the pedagogical purpose, it's better to do it in a more implicit fashion, explicit fashion. So here I write this move to the right I positions for I character in enumerate. So this actually it does not matter you assign which bit to a number. So in other words, you can assign O to the first bit to the right or U to the first bit, but the idea is important. So once we have this, let's do the dictionary and the check strategy. So what we for convenience, I can first have the length of this S, right? Then we assign a result variable. So this is the length, or its final state is what we want to return finally. Then we use a dictionary because originally nothing is scanned, so we regard the exclusive OR result as 0, and we set the index to be -1. Because if you have, for example, the 0 position is not a vowel, so then ending at that position, so you're going to have a substring ending at I, but starting after -1. So you just need to use 0 minus this -1, so you get the length, right? That's why we use -1 here. Then we are going to do a for loop for let's see, I'm going to use R for R in range M, right? So what we are going to do, let's look at this character SR, right? So if character is in vowels in this dictionary, right, then we are going to do exclusive OR of, so also I think I forgot to a current. So you can think this current has some exclusive OR result 0 and starting from -1, right? So this is the initializations. Initializations of dictionary and running exclusive OR result. So what's this? So we are going to do exclusive OR with this the corresponding number with respect to so vowels. So we are going to do vowels character, right? So then we need to do a check. So because starting from the beginning up to the current index R, so we have a exclusive OR result given by the current state of current. So now if this state has appeared in the dictionary, so we can call this dictionary actually more precise last thing, right? So last time I see this one is index 1. So the earliest time this exclusive OR result appeared. So what we are going to check is if current is in the dictionary, if current in D, then we want to find the larger one, so the previous state of the result, and then R minus D current. What does it mean? It means that from the index D current plus 1, then ending at R. So this substring is a valid substring. That is, all the vowels appear even number of times in this subarray. So we get the larger one of this result. Then otherwise, if this current result does not appear before, so if it were in the dictionary, so we don't update the index because the index is the first time this exclusive OR appeared. So if not, so what we want to do is D current, so it's equals to the current index R, right? So finally, after this for loop, we just need to return the result state, right? So this is a full solution to this problem. So let's first do a test. And pass is the last one, so we can use this one to do a quick check. Yeah, it's okay. So now let's submit that. So with this done, basically let's give a quick summary of this thought process. So here, the first thing is that we need to have a good way to monitor the fact that all the vowels appear even number of times in the substring. So here we are using bit manipulations, or more precisely, we are using exclusive OR. What we are using is this operator's cancellation property. Then we reduce this problem to a prototype problem. And then solving this prototype problem essentially is a for loop, but in between we need to carry some information. So I term this as dictionary and check strategy. So with that said, I guess that's it for the current video.